For months, the simplest explanation for 3I Atlas was also the most comforting one: a comet. Strange, yes, but still familiar. Something we already understand. Something that fits neatly into existing models, equations, and historical precedent. But science doesn't care about comfort. And now, a growing body of new data is doing something researchers rarely say out loud. It's breaking the comet explanation piece by piece, not weakening it, not complicating it, flatly invalidating it. Across thermal behavior, composition signatures, trajectory dynamics, and radiation response, 3I Atlas is failing tests that every known comet passes without question. The problem begins with brightness. Traditional comets brighten as they approach a star because volatile ices, water, carbon dioxide, carbon monoxide, begin to sublimate. This process creates a coma, and eventually, a tail. The rate of brightening follows predictable curves tied to distance and solar flux. 3I Atlas does not follow those curves. Its luminosity changes are irregular, delayed, and in some cases inverted. At distances where sublimation should be obvious, nothing happens. Then, unexpectedly, brightness spikes occur where thermal models predict stability. This alone raised eyebrows. But brightness anomalies can sometimes be explained by surface layering or unusual composition. Researchers initially tried to patch the model. Then came the spectral data. When astronomers look at comets, they expect to see certain chemical fingerprints: cyanogen, diatomic carbon, water-related hydroxyl lines. These signatures are so common, they're practically diagnostic. With 3I Atlas, they're missing, or worse, replaced by signals that don't match known comet chemistry. Multiple observation windows failed to detect expected volatile emissions, even when sensitivity-Shackleton thresholds were more than sufficient. The object appears chemically quiet, where it should be screaming. Some attempted to argue this could be a dead comet, an object that lost its volatiles long ago. But that explanation collapses under its own weight. Dead comets don't behave like this dynamically. Without active outgassing, their motion becomes purely gravitational. And yet 3I Atlas exhibits subtle but measurable non-gravitational accelerations. These deviations don't align with jetting patterns seen in comets. The vectors are wrong. The timing is wrong. The magnitude is wrong. You cannot have it both ways. An inert body that somehow produces structured, directional force without mass loss. Thermal modeling makes the situation worse. Infrared observations indicate surface temperatures that are inconsistent with both icy and rocky cometary bodies. Some regions appear too cool, others too thermally stable. Comets are messy thermally. They crack, vent, and shed material unevenly. 3I Atlas, by contrast, shows an unnerving thermal smoothness. Heat is redistributed in a way that suggests internal regulation rather than passive absorption and emission. No known comet exhibits this behavior. Then there's the shape problem. Light curve analysis implies a geometry that is neither spherical nor irregular in the way natural rubble piles tend to be. Instead, the rotation profile suggests a constrained, possibly flattened or elongated structure with stability that defies expectations for loosely bound comet nuclei. Most comets tumble. Their spin states evolve chaotically due to asymmetric outgassing. 3I Atlas rotates cleanly, predictably, as if its mass distribution is balanced in a way nature rarely produces without catastrophic reshaping. One of the most damaging blows to the comet hypothesis comes from dust, or rather, the lack of it. Even comets with weak activity shed dust. Micrometeoroid streams, faint debris clouds, something detectable against background noise. Observations of 3I Atlas show no such trail, no lingering particulate wake, no evidence of material loss its scales instruments should easily detect. This absence isn't subtle, it's glaring. A comet that doesn't shed dust isn't just unusual, It's functionally contradictory. Radiation interaction adds another layer of inconsistency. As 3I Atlas passed through varying radiation environments, including regions of enhanced stellar wind interaction, it showed no reactive behavior. Cometary comas interact strongly with charged particles. They glow, distort, and respond. 3I Atlas remained inert, silent, as if shielded or simply not composed of materials that respond in expected ways. Again, this isn't a single anomaly, it's a pattern. At this point, defenders of the Comet model began leaning heavily on statistical outliers. Rare objects exist, they argued. Nature is diverse. That's true, but science doesn't work on vibes. It works on probabilities. For the Comet explanation to survive, 3I Atlas would need to be simultaneously volatile poor, chemically atypical, thermally regulated, dust-free, dynamically anomalous, and structurally stable. Each of those traits alone is rare. Together, they move from unlikely to effectively impossible. And this is where the language in recent papers begins to shift. You won't see sensational claims. Scientists are cautious. But phrases like inconsistent with known cometary behavior and existing models fail to account for observations are appearing more frequently. These are polite ways of saying the model is broken, not incomplete, broken. Crucially, no revised Comet model has successfully explained all the data at once. Each patch fixes one problem while making another worse. Add internal cohesion to explain rotation, and you lose the ability to explain non-gravitational acceleration. Remove volatiles to explain chemical silence, and you lose the energy source for motion. Invoke exotic ices, and thermal data contradicts you. The framework cannot be saved without becoming so flexible it explains nothing. So what is 3I Atlas, if not a comet? That question remains open, and that's exactly what makes this moment so important. Science advances when old explanations fail. The invalidation of the Comet model doesn't mean we jump to conclusions. It means we acknowledge uncertainty honestly. It means admitting that 3I Atlas belongs to a category we don't yet understand. What's clear is this: calling 3I Atlas a comet is no longer a conservative position. It's a convenient one. And convenience is not evidence. The data doesn't just challenge the comet hypothesis, it rejects it across multiple independent lines of inquiry. When brightness curves, chemistry, dynamics, thermal behavior, and dust production all disagree with a model, the model doesn't get sympathy, it gets replaced. 3I Atlas is forcing that reckoning. And whatever it turns out to be, it's already done something remarkable. It's exposed the limits of our assumptions. It's shown that not every strange object can be folded back into familiar categories. Sometimes the universe hands us something that fails every test because we're asking the wrong questions. And that's where the real story begins.